Welcome back, everyone, to this lecture on the TensorFlow Playground. So we're going to be able to actually visualize and play around with a lot of the topics we've been discussing. Go ahead and open your browser and go to playground.tensorflow.org. I'm going to hop over to my browser and explain what we're looking at. Okay, here I am at playground.tensorflow.org, and it's this really awesome site that allows you to really visualize a lot of the topics we've been discussing about neural networks. Let me explain a couple of the aspects that are on this website. So you start off over here on the left-hand side with the data you want to use. So you have various data sets, and right now, if you go over here, you can select classification or regression. We'll go ahead and just do classification for now. And you'll notice that you have various data sets you can choose, and you're trying to classify between orange points and blue points. So you can click here to get a data set that looks like this, or a more complicated spiral data set, or just two clusters, etc. So let's go ahead and choose this default data set, which is kind of a rim or a ring of orange points, and then in the center we have these blue points. You can also affect the ratio of training to test data. We'll go ahead and just keep it 50-50, and you can also make the test data or training data noisier. So you can add some noise to this. You can see they're more mixed up, but we'll go ahead and bring this down to 0, basically what it was. And you can also play around with the batch size. So the actual batches that you're going to feed in. Then once you're done with the data, you can move on to the features that you want to actually feed in. Basically the properties that you want to feed into your neural network. Here we can just see that we have the X1, which is kind of this horizontal separation between orange and blue. And if you hover over it, you can see it on the right-hand side towards the output. And then X2, kind of this vertical separation, etc. So you're trying to use these two features and let the neurons learn how to use those features on your data set to separate out into two classes. Let's go ahead and make this just a really simple neural network. It's going to have one hidden layer, and we're just going to have this be just one simple neuron. In fact, let's go ahead and just feed in one feature. So we're feeding in one feature, this kind of horizontal separator, and then it goes into one neuron. So let's go ahead and train on this simple singular feature into just a single neuron to see our output. And as you may likely predicted, this isn't going to be such a great classifier because we just have a single neuron and a single input. But we can see a lot of the stuff that we've been discussing. Over here on the output, you can see in black, you have the test loss. So loss is kind of just another word for that cost. Remember our cost function that we discussed. So you can see our test loss, and then you can also see our loss on the training data in gray. So you can kind of see how they compare to each other. And then over here on the top, let's go ahead and pause this. Epochs is just the number of times we kind of feed in this data through our neural network. We can see our learning rate, our activation functions. So you can kind of play around with these. Notice that we have the different activation functions that we discussed. Right now we're using hyperbolic tangent. Then we also have regularization. We haven't really talked about that yet, so we'll kind of leave them as none and 0. And you can also clarify the problem type. So let's go ahead and play around with this. Let's try to make a more complicated neural network. We'll go ahead and take in two features, and then let's say we'll go from 3 neurons to then 2 neurons and see how this performs. So we're going to then run this, and hopefully now we're going to see a much better performance. And you can see here, we are just visually almost getting it to the point where we're correctly classifying kind of all these blue points and those orange points. So in order to fix this, what we can do is try adding some more neurons or playing around with the hidden layers. But let me go ahead and pause it here to kind of show you what these lines represent. So right here, these lines represent the outputs from either the features or a neuron into the next neuron. So here we have kind of a dense network because every neuron is connected to every other neuron in the next layer. And if you hover over these, you can see that they have weights to them. So you can actually click on this and then adjust the weights yourself, so you can play around with that. Notice here I can adjust weights to maybe like 0.81 and see how that performs, etc. But also, remember we discussed bias, and if you click on a neuron here, there's a little tiny square, and that's actually the bias term. So everything that we've been discussing so far is actually visualized here. We can see the weights, these inputs from one neuron to another, the biases, and the thicker the line, that means the higher the weight. So really great visualization, a really fun tool to work with. Let's go ahead and see if we can improve on this. I'm going to add in one more hidden layer, and let's add in kind of 3 neurons on these guys. Let's see if we run this, if we get better results. Whoops, let me reset this, and let's run this again. Okay, we can kind of begin to see that, yeah, we're really fitting the data well, and our test loss is essentially 0, and our training loss is 0. So essentially now we have kind of this perfect classifier. And what's really cool is if we pause this, we can kind of see individually what each of the neurons are doing. And notice as we continue on through our network, we get higher and higher levels of abstraction until the final end. We can see here that essentially one of these neurons is doing all the work, and we really get the shape of that highest level of abstraction, which is essentially that circle in the middle versus kind of that spiral on the outside. So let's go ahead and test this on a much more complicated data set, such as this spiral data set. So if we run this, notice here that even though we performed really well on that previous data set, with this much more complicated data set, it's not able to really classify it that well. You can see here it's kind of struggling to get in that spiral shape. So it's trying to really learn and test against the training data, but notice here we're still really not there. So let's go ahead and see what we can do to improve this. So I will pause this. So something we may need to do is just add in more hidden layers. But remember, we can also change our activation function. So we're going to change this to kind of that rectified linear unit. And let's go ahead and just kind of go crazy here, add a bunch of more neurons. And this is something you can really play around with. So let's add in 5 hidden layers. Why not? And I'm really just kind of choosing these arbitrarily to see how this works. And remember, the more neurons, more hidden layers, the longer this is going to take. So I'm going to add in kind of 4. So we'll go 6, 6, 6, 6, 4. You can really play around with this however you want. But let's go ahead and run this now. Again, more hidden layers. It's going to take a lot more as far as training time. But you can kind of see here our test loss is slowly decreasing. Now it seems like it's plateauing. And then we kind of get a breakthrough here. And it's kind of struggling, but you can see here it's really trying its best to make out that spiral shape. So even with the rectified linear unit activation and all these hidden layers, we can tell that this is still a really hard problem to solve, but it is trying its best to get into that spiral shape. So I'm going to kind of go to the max here. So let me pause this and let me add in 8 neurons to each of these layers and see how that kind of affects performance. And we can even add 6 hidden layers maximum. So let's go kind of all out on this and see how this works. So that's not to say as a general problem solving strategy, you should just go crazy with neurons and hidden layers, but I kind of want you to see the effects of adding a lot of stuff here. So again, rectified linear unit, tons of neurons, 6 hidden layers. So we have a deep network here. Let's go ahead and run this and see how it performs. So again, the more neurons, more layers, the more time it's going to take to actually learn on this data. And what's really cool is you can see the higher level abstractions as you kind of visit these neurons. So you see the visualizations here, and kind of towards the end, you can see the spiral shape really begin to come out. So I jumped forward in time a bit, but you can see here that we have kind of a much lower test loss than what we initially started with, and then a training loss. But you can see that we're definitely making out the spiral shape a lot more clearly than our first neural network. So I encourage you to really play around with this. We can go ahead and pause this now. Play around with the learning rate. So obviously, the lower the learning rate, that means the longer this is going to take to train, but you may get more accurate results. So I can kind of refresh this and see here that it's going to take a lot longer to train this if you have a much slower learning rate. Or if you refresh this and go to a much higher learning rate, this is going to learn kind of a lot faster. You can see here, a really high learning rate kind of ruins the whole thing and says, okay, I'm just going to classify everything as blue. So lots of things to play around with here, but hopefully you can now have a really good visualization of all the topics we've been learning about. So again, playground.tensorflow.org, really fun website, really awesome website to play around with. I really encourage you to check it out and visualize everything we've been talking about. Coming up next, we're going to discuss in full detail the mathematics behind the neural network theory that we've been talking about, and then show you how to manually compute all that in Python. Thanks, and I'll see you at the next lecture.